So hello everybody. Now I'm going to talk about dimensionality reduction. So what dimensionality reduction does is it basically reduces the spatial dimension of your components or features in the data set. So for that what I've done is and for that I've used the PCA, principal component analysis. So what it does is there's also another one, LDA, which is the linear discriminant analysis. So both of these are used for dimensionality reduction. So first I've imported all the necessary packages, and then I've imported my data set, which is package delivery route optimization. Using I use the pd.read underscore CSV, which is used to read a CSV file. Then I've used label encoder. So what I've done is I've encoded all the categorical columns such as origin, destination, and priority using label encoders, and then I've converted my values, the time window start and time window end, into numerical by applying a lambda function. So what it does is basically it takes the time. For example, if the time is 7:30, then it shows 7.5, meaning 7 hours. zero point 0.5 is equal to 30 minutes, which is half an hour. So 7 hours and 30 minutes. So it would be 7.5. So like that, I've done it for all the data, all the data, like time window start and time window end, all the values of time window start and time window end. Then I've taken my features as distance, kilometer, priority, time window start and time window end. Then I'm using a standard scaler to scale the values so that they are closer in range, and it reduces the outliers and improves the accuracy of the model. Then I've used PCA, and I'm taking two components. So basically I'm converting all the four into two components, meaning I'm reducing the dimension. So there are four features. I'm reducing it into two and plotting it on a 2D plane. So then what I'm doing is I'm fitting the scaled values, the X scaled values. I've scaled the values. So that one I'm fitting it into the PCA. And then uh, this is my first PCA, like principal component 1, and this is my principal component 2. So like I have two components, so this is the first component and this is the second component. Then I am plotting the dimensionality reduction. So what it does is I am using a scatter plot using C-bond. Then PCA1, PCA2, data is DF, hue is priority. Like based on the priority, the values will change. For example, 0. So this has the highest priority. Then 1, medium, and 2, the yellow ones are low priority. So based on that, I am giving the colors. Then palette is the color palette, and S is 60, size is 60. Then I'm giving the X label and Y label as principal component 1 and principal component 2. And the legend says priority because I am plotting this based on the priority colors. And then the grid is true. So what the plt.grid true does is it gives you the grid behind the plot. So if you give false, you won't get the grids. Then plt.show is for visualizing, sorry, is for displaying the plot. So this is how you do PCA dimensionality reduction. There's also the LDA dimensionality reduction, which works in a similar way. Thank you.